My name is Christina Thomas, and I'm one of the full-time conservators in the BYU Library. And we were approached by some of the curators of special collections to find out if we could identify whether arsenic was present in some of the end papers and the coverings of some of the books down there. There's a project that started out of the University of Delaware called the Poison Book Project, where they've been identifying Victorian-era bindings with green paper and green book cloth. We had a range of greens here that were within the greens the Poison Book Project has identified so far. The project has a database, so if any of the books we've identified as having high levels of arsenic aren't on their database, then we will add them to their database as well.
This is an 1871 edition of the Book of Mormon. It was printed here in Utah in Salt Lake City, and as you can see, the end sheets are a violent green color. We wanted to check and see if it had arsenic in the end sheets, and it did. It was pretty high. I think it was about 7,300, which is a lot higher than it should be.
What we're looking at here is an 1852 edition of a French Book of Mormon. It's the lowest of all the books that we tested in terms of arsenic levels because, as we can see, it's less green and more bluish, and it did have more copper in it. So what we've noticed is that the vibrancy of the green tends to correlate with the level of arsenic in parts per million.
This is a handheld X-ray fluorescence spectrometer. And so basically what that means is that it's just a little handheld X-ray gun that allows us to use X-rays that are generated in here to bombard our sample with the ions so that then it alters the electrons, excites the electrons, moves them out, and then when they go backfill those electron orbitals, it gives off energy. And that energy is what we track here at a given energy range that corresponds to each element. And so with this little gun, we can see the elemental composition of samples. So we use this a lot with rocks and with soils, and here you can see that we can do it with books, which is pretty cool. And it goes everywhere from percent levels down to parts per million, and so you get quite a range of detection limits with it. And we use it in the field, we use it in the lab, and it's nice because it is field portable and has so many different applications.